Hi everyone. In this video, we will discuss about the introduction to classification methods. So, these are the key topics in our presentation. The decision tree induction, base classification, rule-based classification, model evaluation and selection, Bayesian belief networks, support vector machines, and other classification methods. So, what is decision tree induction? Decision tree is a supervised learning method used in data mining for classification and regression methods. So, it is a tree that helps us in decision making purposes for our data. The decision tree creates classification or regression models as a tree structure. It separates a dataset in smaller subsets. At the same time, the decision tree is steadily developed. Decision trees can deal with both categorical and numerical data. So, mas flexible yung decision trees kasi it can deal with categorical and numerical data. So, ang decision tree ay mayroong root node, branches, and leaf nodes. Tapos, ito yung example. So, ito example, the following decision tree is for the concept of buying computer. So, it indicates whether a customer at a company is likely to buy a computer or not. So, yung internal node, nagre-represent siya sa test on an attribute. Tapos, yung diff node naman, nagre-represent siya ng class. So, what are the benefits of having a decision tree? It does not require any domain knowledge. Tapos, it easy to comprehend. Three, pruning approach. Ito ay pine-perform para tanggalin yung mga anomalies due to noise or outliers. So, may dalawa siyang approach. Ang pre-pruning and post-pruning. The tree is pruned by halting its construction early sa pre-pruning. Sa post-pruning naman, it removes a sub-tree from a fully grown tree. Next is the cost complexity. The cost complexity is measured with the following two parameters. Una is number of leaves in the tree. And pangalawa is error rate of the tree. So, mga key factors. Entropy refers to a common way to measure impurity. In the decision tree, it measures the randomness or impurity in datasets. So, ito yung makikita. So, minimeasure nyo yung impurity sa mga data. Yung pangalawa is information gain. Refers to the decline in entropy after the dataset is split. It is also called entropy reduction. Building a decision tree is all about discovering attributes that return the highest data gain. Ito naman yan. So, why is Decision tree useful. It enables us to analyze the possible consequences of a decision thoroughly. It also provides us framework to measure the values of the outcomes and the probability of accomplishing them. It can also help us to make the best decisions based on existing data and best speculations. So pag ginamit ng decision tree, makakabuo ka ng mas magandang desisyon. Hence, the algorithm used to build the decision tree is referred to as recursive partitioning. The algorithm is known as CART or the classification and regression trees. Next is the decision tree algorithm. Decision tree algorithm may appear long, but it is quite simply the basis algorithm techniques. The algorithm is based on three parameters. So, the tree, the D, attribute list, and attribute selection method. So, yung D is a data partition. Ito yung entire set of training tuples and the related class levels or input training data. Then the parameter attribute list is a set of attributes defining the tuples. So, yung parameter attribute naman, dinedefine niya yung D parameters. Attribute selection method specifies a heuristic process for choosing the attribute that best discriminates the given tuples according to class. So, attribute selection method process applies an attribute selection measure. Next is the advantages of using decision trees. Decision tree does not need scaling of information. Missing values in data also do not influence the process of building a choice tree to any considerable extent. A decision tree model is automatic and simple to explain to the technical team as well as stakeholders. So, automatic siya and simple. Compared to other algorithms, decision trees need less exertion for data preparation during pre-processing. It also does not require a standardization of data. The next topic is Bayes classification. So, Bayesian classification is based on Bayes theorem. So, based sa Bayes theorem. Bayesian classifiers are the statistical classifiers. Bayesian classifiers can predict class membership probabilities such as the probability that a given tuple belongs to a particular class. So this theory expresses how a level of belief expressed as a probability. So itong Bayes theorem came into existence after the Thomas Bayes, who first utilized conditional probability to provide an algorithm that uses evidence to calculate limits on an unknown parameter. So, ganito express yung yung Bayes theorem. Ganyan. So doon yung x and y are the events and p times y are not equal to 0. P times x divided by is a conditional probability that describes the occurrence of event and x is given that y is true. Next is p times y divided x is a conditional probability that describes the occurrence of event Y is given that x is true. P times x and p times y are the probability of observing x and y independently of each other. This is known as the marginal probability. Ikaw na.
Rule-based classification. Rule-based classifiers are just another type of classifier which makes the class decision depending by using various if-then rules. We can express a rule in the following from if condition, then conclusion. Let us consider a rule R1. If age equals youth and student, then yes. Then by underscore computer equals yes. The if part of the rule is called rule antecedent or precondition. The then part of the rule is called rule consequent. The antecedent part of the condition consists of one or more attribute tests, and these tests are logically ended. The consequent part consists of class prediction. We can also write R1 as parent open parenthesis age equals youth close parenthesis student equals yes and bias computer equals yes. If the condition holds true for a given tuple, then the antecedent is satisfied. Rule extraction. To extract a rule from a decision tree, one rule is created for each path from the root to the leaf node. To form a rule antecedent, each splitting criterion is logically ended. The leaf node holds the class prediction, forming the rule consequent. Rule induction using sequential covering algorithm. Sequential covering algorithm can be used to extract if-then rules from the training data. The decision tree induction can be considered as learning a set of rules simultaneously. Algorithm sequential covering. Input D. A dataset class labeled tuples. Attributes underscore vals. The set of attributes and their possible values. Output a set of if-then rules. Method rule underscore set equals open parenthesis and close parenthesis colon double slash initial set of rules of learned of initial set of rules learned is empty. For each class C2, repeat rule equals learn underscore 1 underscore rule open parenthesis D attribute underscore vals C close parenthesis colon. Remove tuples covered by rule form D colon until termination condition colon. Rule underscore set equals rule underscore set plus rule colon double slash add a new rule to rule set and 4 return rule underscore set colon. Rule pruning. Rule is pruned due to the assessment of quality is made on the original set of training data. The rule may perform well on training data but less well on subsequent data. That's why the rule pruning is required. The rule is pruned by removing conjunct. The rule R is pruned if the pruned version of R has greater quality than what was assessed on an independent set of tuples. FOIL is one of the simple and effective method for rule pruning. For a given rule R, FOIL underscore prune equals post minus neg slash post plus neg, where post and neg is the number of positive tuples covered by R, respectively. Model selection and evaluation. Model evaluation is a method of assessing the correctness of models on test data. The test data consists of data points that have not been seen by the model before. Model selection is a technique for selecting the best model after the individual models are evaluated based on the required criteria. Model selection and evaluation is a hugely important procedure in the machine learning workflow. This is the section of our workflow in which we will analyze our model. We look at more insightful statistics of its performance and decide what actions to take in order to improve this model. This step is usually the difference between a model that performs well and a model that performs very well. Metrics and scoring. Let's say we have two hypotheses for a task H open parenthesis X and close parenthesis and H open parenthesis close parenthesis X. How would we know which one is better? Number 1. Measure the accuracy of both hypotheses. Number 2. Determine whether there is any statistical significance between the two results. If there is, select the better performing hypothesis. If not, we cannot say with any statistical certainty that either this one or the other one is better. Nasa puntang aki ka. We also have names for these classifications. Our true positive and true negative are our correct classifications. As we can see, in both cases, the actual class and the predicted class are the same. The other two classes in which the model predicts incorrectly can be explained as follows. False positive. When the model predicts 1 but the actual class is 0, also known as type 1 error. False negative. When the model predicts 0 but the actual class is 1, also known as type 2 error. Overfitting. Overfitting is a key consideration when looking at the quality of model. Overfitting occurs when we have a hypothesis that performs significantly better on its training data examples than it does on the test data examples. The model has essentially not identified general relationships in the data, but it instead has focused on figuring out exactly how to predict this one sample set. This can happen for a number of reasons. 1. The learning process is allowed to continue for too long. Second, the examples int he training set are not an accurate representation of the test set and therefore also of the wider picture. Third, some features in the dataset are uninformative and so the model is distracted, assigning weights to these values that don't realize any positive value. Cross-validation. Cross-validation can be considered under the model improvement section. It is particularly useful method for smaller datasets. Splitting our data into training and test data will reduce the number of samples that our model receives to train on. In cross-validation, we run our modeling process on different subsets of the data to get multiple measures of model quality.
So let's proceed now to Bayesian belief network. Next po. Bayesian belief networks specify conditional probability distributions, also known as belief networks, Bayesian networks, or probabilistic networks. A belief network allows class conditional independencies to be defined between subsets of variables, provides a graphical model of causal relationship on which learning can be performed, can use a trained Bayesian network for classification. Two components that define a Bayesian belief. We have directed acyclic graph and a set of conditional probability tables. What is directed acyclic graph? Each node in a directed acyclic graph represents a random variable. These variables may be discrete or continuous values. These variables may be correspond to the actual attribute given in the data. We have here the representation of directed acyclic graph. The arc in the diagram allows representation of causal knowledge. For example, dito is yung lung cancer is influenced by a person's family history of lung cancer, as well as whether or not the person is a smoker. It is worth noting that the variable positive X-ray is independent of whether the patient has a family history of lung cancer or that the patient is a smoker, given that we know the patient has lung cancer. Another component, we have conditional probability table. The conditional probability table for the values of the variable lung cancer, showing each possible combination of the values of each parent node, family history, and smokers as follows. Their machine. Support vector machine or SVM is one of the most popular supervised learning algorithms, which is used for classification as well as exclusion problems. However, primarily it is used for classification problems in machine learning. Types of SVM: linear and nonlinear SVM.
First, linear SVM is used for linearly separable data, which means if a dataset can be classified into two classes by using a single straight line, then such data is termed as linearly separable data. And classifier is used called as linear SVM classifier. Then nonlinear SVM is used for non-linearly separated data, which means if a dataset cannot be classified by using a straight line, then such data is termed as non-linear data, and classifier used is called as nonlinear SVM classifier. Hyperplane and support vectors in the SVM algorithm. Hyperplane. There can be multiple lines, decision boundaries, segregated classes in n-dimensional space. But we need to find out the best decision boundary that helps to classify the data points. This best boundary is known as the hyperplane of SVM. Support vectors. The data points of vectors that are the closest to the hyperplane and which affect the position of the hyperplane are termed as support vectors. Since these vectors support the hyperplane, hence called a support vector. Other classification methods. K-nearest neighbors and random forest. K-nearest K-nearest neighbors. A type of lazy learning as it does not attempt to construct a general internal model, but simply stores instances of the training data. Classification is computed from a simple majority vote of the k-nearest neighbors of each point. Advantages: this algorithm is simple to implement, robust to noisy training data, and effective if training data is large. While the disadvantages of this method, if you need to determine the value of k and the computation cost is high, as it needs to compute the distance of each instance to all the training samples. Next, we have random forest. It is a meta estimator that fits a number of decision trees on various subsamples of dataset and uses average to improve the predictive accuracy of the model and controls overfitting. The subsample size is always the same as the original input sample size, but the samples are thrown with replacement. Advantages of random forest. Reduction in overfitting in random forest classifiers is more accurate than decision trees in multi-phase. While the disadvantages of this method, it is low real time. It is low in real time prediction, difficult to implement, and complex algorithms. Next is stochastic gradient descent. A simple and very efficient approach to fit linear models. It is particularly useful when the number of samples is very large. It supports difference loss functions and penalties for classification. Its advantages: efficiency and ease of implementation. Disadvantages: it requires a number of hyperparameters and it is sensitive to future failure. Next, the last, logistic regression, a machine learning algorithm for classification. In this algorithm, the probabilities describing the possible outcomes of a single trial are modeled using a logistic function. Advantages: logistic regression is designed for this purpose, for classification, and is most useful for understanding the influence of several independent variables on a single outcome variable. Disadvantages of regression: it works only when the predicted variable is binary, assumes all predictors are independent of each other, and assumes data is free of missing values.